Hello students, in this video we will discuss about tolerance and equivalence relations. We will discuss classical equivalence relation, classical tolerance relation, fuzzy equivalence relation and fuzzy tolerance relation. Let us see what is meant by tolerance and equivalence relation. The basic three characteristic properties of relations are reflexivity, symmetry and transitivity. Suppose we have a relation R and then we can say that that particular relation is said to be reflexive. When we draw a graph, if every vertex in the graph originates a single loop, that means if we suppose say we have three elements x1, x2, x3 in a relation R. If we have a membership from x1 to x1, x2 to x2 and x3 to x3, that is called a single loop, and if such situation exists, that relation is called a reflexive relation. Next is symmetry. A relation is said to be symmetric if for every edge pointing from vertex I to vertex j, there is an edge pointing in the opposite direction, that is from vertex j to vertex I. Suppose say this is our vertex I and we have another vertex j. So if we have an edge pointing from vertex I to j, there should have an opposite edge pointing from j to I. So this type of relations are called symmetric relation, and a relation is said to be transitive if for every pair of edge one pointing from vertex I to vertex j and another pointing from vertex j to k, then there should have an edge from vertex I to vertex k. So that relations are called transitive relation. Next is classical equivalence relation. Let us take a relation R defined on a universe X and it is defined from X to X. This is called an equivalence relation if these three properties are satisfied. First one is reflexivity. That means there should have an edge between the node. That means a single loop should be present. So psi r of xi comma xi equal to 1. Next is symmetry. That is psi r of xi comma xj is equal to psi r of xj comma xi. Next is transitivity. We'll have xi, xj and xj and xk, that is equal to 1. That means there have a membership psi r of xi comma xk equal to 1. Next is classical tolerance relation. Tolerance relation R1 on the universe X is 1 where the only properties of reflexivity and symmetry are satisfied. It does not deal with transitivity. It is called proximity relation. And from a tolerance relation, we can create an equivalence relation. So an equivalence relation R can be formed from tolerance relation R1 by n minus 1 composition within itself. So R1 raised to n minus 1 equal to R1 composition etc. up to R1 composition n minus 1 times will yield the equivalence relation R, where n is the cardinality of the set that defines R1. Next is fuzzy equivalence relation. It can also be called as similarity relation, and the relation R defined over x to x. This is called the fuzzy equivalence relation with these three properties. First one is reflexivity. Say mu r of xi comma xi equal to 1. Symmetry xi comma xj equal to xj comma xi, and transitivity xi comma xj equal to lambda 1 and xj comma xk equal to lambda 2 should have an xi comma xk. Next is fuzzy tolerance relation. So a binary fuzzy relation which possesses the properties of reflexivity and symmetry is called fuzzy tolerance relation, also called as resemblance relation. we can create a fuzzy equivalence relation from a fuzzy tolerance relation by the same procedure, that is by n minus 1 composition within itself. So R1 n raised to minus 1, n minus 1. R1 composition etc. up to n minus 1 will yield the fuzzy equivalence relation R, where n is the cardinality of the set that defines R1. Thank you.